Testing, testing, testing. Okay. Testing, testing. Hello. Hello. All right. Okay, where is this? Giant causeway in Northern Ireland. Giant causeway. Okay, seems pretty cool. But alright, let's see. We are here. We are here. Let me see if I can up the mic a little bit. Let's see. Maybe we can go up like this. That would be good. But it look crazy now. Eh. Just do like this. Okay. Okay. So last time we wasn't able to figure out like can we optimize this better? Because first thing is we cannot use a sliding window because it says negative. So we don't know if we can shrink left or remove. It doesn't work, right? So we want to know, what we want to know is as we go through these, right? For example, 03, out of all these, which one make us sum to k, right? So that means there gotta be a quick way to tell us right how to do that. Using screen too much. So like if we want to know, and another thing is that, right, we need to quickly know if any point prefix we swept before, right, is a potential candidate, right? So like for example at 02 we need to know and the sum is p2, right? Right, we want to know we want to know if so let's say the sum is ps2. We want to know if ps2 minus k we've seen before, right? Because ps2 minus k um, right? So like let's say the current sum is 4 and we're looking for 3, right? Right, so say we have looking for 3, prefix sum equal, let's say, right, we're looking for 3. That mean we're looking for 4 minus 3 equal 1, right? So because if we found, let's say, ps0 equal 1, does that mean the 1 2 is the value, right? Right, because because 1 plus 3 equal 4, right? Right? Yeah, so in other words, ps2 minus k so this is because this is ps2 minus k equals sum ps1 0, right? Let's say, right? So that means ps0 plus k equal to ps2, right? To sum total to k, right? So we just basically we put k to one side and we got ps0, right? Right, because if you want to find the k, we actually need to just found the minus k, right? If we seen that, right, then yeah, so let's do that. So let's call this this is what we call this. This is K, right? Right. So we probably want to optimize the serve. Right. So now we know now. So let's run through some of the example in here, right? So we have looking for 2, right? So our thing started empty. So first we got the sum is this. So we gotta look for 1 minus 2, right? So we're looking for -1, right? So this give us 1, right? Got 1. And we keep advancing. The 1 plus 1 is 2. Okay. Okay, so 2. Oh, we have to count for when. So this gotta start out at 1. Right? So you can start out 1, okay? So 2 minus 2 is 0, right? Is 0 in? Yes. Then the count gonna be 1. It's all about if we know if we've seen that one before. Okay, if we not seen, we add it to the map. And finally we got 3 here. Okay, so basically we want this and this, right? And 3 minus 2 is 1, right? Is 1 in the map? Yes, 1 is in the map. Then increment by that same one, right? So this is the marker for stuff, right? So let's do it with the second example. Looking for 3. We want to always start out with this. And 1, right, is 1 in so 1 minus 3, right? -2, right? Is have we seen -2? We know. then we put this in here. So this is 3. 3 minus 3 is 0. Have we seen 0? Yeah. So this is counts at 0. Right? We've seen 0, right? So it's gonna be plus to that, right? Be 1. So 1, 3, 6. So 6 minus 3 is 3. Have we seen 3? Right? So we want this, right, and this, right? So So actually we want to store the sum, right? Yeah, that is wrong here. So this actually is the sum. So this is actually 1, yeah. This is still correct. This is 3, sorry. Right. So we want to store all the previous prefix sum we know. Right. So because 3 is in, so we plus 1 here. Right, so the sum is actually this number, the k. Right, there we go. So now we have that. Let's see. It's actually 0, 1 because of the case where it is 0 here. So let's say, do we really need the array now, right? Prefix sum, just call this PS, right? So PSF, PS equals 0, right? So PS plus equal num sign. Right, so now we want to know if PS minus K, right, is not in the map, then PSF of this sum gonna be equal to PS. No, go to 0, and then if it is in, okay, it's 1, right? If it is in, right, PSF PS plus 1, right? So right, so this basically return BFS of K if K in PSF have 0, right? error 2. If PSK is not in that, then 1, right? Okay, so first let me run through this. So -2 is not in, then we put this sum in here, right? Then if 0 is in, right, then this is gonna be okay. So first 1 not in, put this 1, right? Else if actually in this case 3, 0 is in, else PSF PS, right? If and if PS not in PSF, right? So if we found the value, like in this case 0, right? The same thing happened here, but gonna be PSF of PS minus K, right? I think so. Okay, wrong. Okay, let's see. Just print the PS. Okay, so 1 become 1 1 good. Why is it 1? So let's look back at this example. So we got -1 is in, no, then put this here. 2 1 2, yes, 2 is in, then we put 2 here with 1. Right here we got 3. 1 is in, right? Then oh. So we got plus this, right? There we go. This is actually K, right? So if PSK is not in, then we say prefix is not in PSF. Okay, in the case that we couldn't found it, we just put whatever prefix it is. In the case that we found it, we actually have to add it to K, right? I think this should be it. Okay, yeah, here 2 here. So 1, okay, 3 here, right? 3 minus V0, yeah, so 3 got 1 here, and 6, yeah. What's wrong with this case? Oh, we have to watch out for the case where K goes 0, right? So K goes 0 here. So maybe is a edge cases. Okay, so what's wrong with this? So the sum here is 1. We're looking for 1, right? Okay, so 1 here minus k. Okay, 1 minus k is 1. Is 1 not in? Then we put the prefix 1 here in the 1, right? Right, so if k equals 0, right? Then we have this is correct map. So we still don't know what is the how to handle the case when k equals 0. When k equals 0, everything else, guess what? What is the view here? So when should we update count? That's the thing that I think we did wrong here. We only update count here, right? I think so. So um okay, run through this example, we found 2 here, which is wrong, right? Okay. So some of our logic is not correct. Maybe we should count separately, right? Right. I think so. Okay, so we found the 0, then I think this count here is if PS minus K is in the frequency, right? Then the count gonna be plus equal, right? Like that. So we just return count here. So we broke some case. Right? What's wrong with this case here? What did we do in that case? It doesn't. Okay, in the practice case too. Something that off by 1 or something is messed up. we haven't seen it, then we add them, right? We've seen it. If we seen it, we've seen it, then the current sum as well, regardless. Oh, yes. This one, right? Okay, so we still mess some things up. Did we off by 1 here? And then this case is negative, right? So let's see, why does it have 2? So this is just gonna be plus 1. If we've seen it, then it's gonna be k, right? If ps minus k, right? Something off there. We got 3 here. Why does it become so 0? Okay, and 0, 2, 0, 3 here, right? Oh, it's gonna be this, right? Five. Why is it 5? Oh, it's 3 plus 2. It's just gonna be plus 1? Right? We're off by 1 here. I think it's gonna be this, right? Right, so let's run through this and see. So plus equal 1, right? Or 1. Struggling here. Right, so at every index, right, if we see so let's formalize them again. If we have current prefix is this, if ps minus k, we've seen the value before, then so this is at index I, index j, right? So then ij gonna be ps minus ps plus k, right? Okay, so that's what we want, right? Right, so if we seen any index, in this case we just need to count the value. That means if we seen if ps minus k, if we at any particular value of ps, if we seen psk before, then the count gonna be, if we seen 2, right, that means you can have plus 2, right? So right, so which is this, right? This is our formulation, right? Somehow we find these values. So then count gonna be plus equal to whatever the value of the map of the frequency of ps minus k, right? Right, and then we have to save the ps in the map regardless, right? So first we gotta ask if ps not in psf, then psf ps 0, because regardless we gotta store them, right? So then we don't have to do this, right? So then we just need to ask, okay, if ps minus k is in the map, right, then here we say that count gonna be whatever that is, right? Like that, right? We did something wrong. Right, so we have the expect count 0, right? So we look for if is it in, if it is not in, okay, so this is 0 1 0 1, right? Oh, may at okay. So this has to go be after, right? Because then we might not be miscounting, right? Yeah, there we go. So we found something, then we update, right? So this is like take the map if the current sum. So basically update the current sum map. Look for current sum minus k, because if we because this gives us the starting point I, by which ij, right, the subarray ij gonna be current sum minus current sum minus k, right? Right, or equal to k, right? So if we store every prefix and at any particular one we check if the minus k is in, because for the fact that if we seen the value ps minus k, right, this one, that means or the subarray, if that is found, is right, is actually I plus 1, right, to j, right? Right, if we found something that is ps minus k, right, so then ps minus ps plus k, right, equal to k. That means the subarray is actually from here to here, right? Or the subarray is right, something like that. Think, okay, let's see if it works. Submit. There we go. Okay. So looking for, first we gotta save every prefix sum. If prefix minus k is found, then count gonna be equal to k is found in map, then count is that map prefix minus k, right? Okay, we have only this. Oh, we done this. We only have this. Oh, which I don't know. Okay, let's take 3 minutes break. Um, 3 minutes break. Bathroom. All right, be right back. Okay, I'm back. Let's see. Uh, this is the. I think this is harder than medium. This one. This is dynamic programming. How do we know? Like we add how many? Do we just try to add? Um, bet from this to the number, right? So the only thing we know is once we hit the power of 2 here, we can subtract them as one of the optimization. Right? It seems like that's what this does. So let's do some more test case, right? So let's say we do some arbitrary like 23. My prediction is okay, hold on. Rampage. So we have 23, right? Do somehow we want to go to the next. What is the next power up to? Do we want to go to 32? Or do you want to go to 16? Right, 16 is we go to 23, right? What is the binary of 23? Binary of 23. 1011, okay. Minus 23 is 9, right? So 9 can become, right, 2 to the 0, right? So that can become 8 plus 1, right? So that's going to be 2 to the 3 plus 2 to 0. And then, so that is 2 step to the right, minus like to the left. And then we have these 2, right? It's gonna be plus 2, right? So then that's gonna be 4, right? So 23 minus 16 is 7, right? 7 is gonna be 2 to the 0. Okay, so 7 gonna be what? 4 plus 3, 4 plus 3, right? Or 4 plus 2 plus 3, right? Plus 1, right? So this give us so either you go to 16 or you go to 32, right? Go to 32 seems like there's 4 steps, right? So now you want minus 7, right? Or minus 4 minus 2 minus 1, right? So after you go to 16, you can subtract, right? 16, which is 2 to the 16 is what? 2 to the 4, right? So this is also gonna be 4 steps. Is that true? 23. 23 is 3. Oh. How do you go? Oh, sorry. Let me put this away. Okay, so once you hit 32, because that's what I'm thinking they do it, right? For example, we got 52, right? 54. You want to go to 64. That is 10. 10 gonna be broken into what? 9 plus 1, right? So you add it. Wait, hold on, let me try. You're gonna have to go to 64. When you go to 64, you need 10. Right? 10 gonna give you. What's the best way from going to 64? They're saying going to. They're saying going to 64 just need 2 steps. Oh, okay. 10 here is gonna be 9 plus 1, right? So either or. So you have 9 plus 1, you got 2, 8. Right? So, okay. So that is correct. So that is 2 steps. So this is. Oh, you don't want to do 9 plus 1 because that will be more, right? You want a minimum step. So that is 8 plus 2. Right? Or you can do 3 plus 7, 4 plus 6, and so on. Right? 5 plus 5, which is not great, right? Whatever. Right? So coming back to 23 to 32, right? So they're saying you only need 3 steps. I'm not sure how it do that. From 23 you want to go to 32, or you go back to 16, right? Right? So 9 here you got 8 plus 1, you got 7 plus 2, you got 6 plus 3, you got 4 plus 5, and so on, right? So out of these, the only candidate is 2, 3 plus 2, 1, right? And then after you got to 32, you subtract 2 to the 5, right? That's it. I think that's what I'm gonna approach it. So maybe we find the biggest 2 to the x, 2 to the j less than or equal to the number less than or equal to 2 to the I here, right? Then, right, once we hit the 2 to the power, right, we can so yeah, so this is maybe, that is my theory. So n is so let's say we have some random number like what, 65, right? The 65, you either want to go back to 64, or what is the next one? 2 to the 7 is 2 to the 7 is 28. Sorry, my bad. 128. Okay. So we want subtract 1, right? So that's 1. And minus 1. So that is 2. Right? Or we want to do 128 minus 65. That's 63. 63, we gotta find all the numbers that sum to them. One plus 6, 2, 5. Right. So 61 plus 62, 2 plus 2, and we keep divided by 2, find them. Right. So it'll be 31 multiplied by 2. So that's only one observation we've seen so far. It's one which can reach, but then the next problem is we're gonna have to find what is the minimum some number by the power of 2, right? So we find the then n minus 2 of x, right? Go to some s, right? We need to figure out what is s in terms of smallest number in terms of 2 to the x, right? Right. So that means you want to break down 63 into a power of 2, right? So say 10, you can do, you know the value is going to be 10, so you can always add, right? S or minus, right? Until until it go to 0, right? So you're going to add 1. So 10 is how many power of 2, right? So we're going to loop from 1 to 1 plus 9. So 1 is the power of 2. That's one operation, right? So it's going to be 9 plus 1, right? Or 2 plus 8, right? And so on. So 10 minus 1, right? If we keep minus 1, 9, 8, 7, 6, 5, 4, 3, right? 2 and 1, and finally 0, right? So now I need a space. My keyboard away. This, some light in here. Okay. So now, if you add 1, right, you know that it's gonna take one operation. If you add 2, you can minus 1, or you can just minus 2, right? So, but regardless, it's gonna be the same operation, right? So minus 2. This is minus 1. So if you add 3, right? You add 3, you can either minus 1 or you can minus 2, right? So minus 1, you go to 2, which is, you already know that has had one operation, right? Or you can also minus 2, so regardless, we're gonna get one operation. 1 plus 1, we're gonna take 2, right? Because 3 cannot minus, right? And now we have 4. Number operation we can do is 3 minus 1, 3 minus 2, 3 minus 3, right? Oh no, power 2, right? So that means 3 minus 1, 3 minus 4 minus 1 is 3, which is, we already know is 2. 4 minus 2 is also one operation plus whatever's in 2, right? So that's 2, right? So it's gonna be 1 plus 2 is 3, or 1 plus 1. So this is 2. So we landed in 4. The operation is that, so 5. Again, minus 1, minus 2, minus 4, right? So it's 4. It's gonna be, so 5 had some option of this guy, this 2, so that's 3, or 1 plus 2 is 3, right? Or 1, right? 1 is 1, so that's 2. So this is 2. right? So basically what I'm thinking I'm gonna do is find the max, the 2 to the power less than this, 2 to the power greater than this. Then we do and then we minus them, right? And minus this, give some s, and then we need to keep subtracting, right? Like that, I think. So 5 gonna be equal to, because 2 operation, because it's gonna be 2 to the 2 plus 1, right? Oh no, 3, right? So let me try that, see if it works. Okay, so first we gotta find the left power of 2, right? So 2p r2p 0, right? And so this 4 okay, so we can keep shifting, right? So bit go to 2 to the 0, right? That is 1. So while b is less than n, right? Less than or equal to n, right? So we're gonna keep shifting, right? To the left 1, right? So basically so for example, right? So like we have 23, we want to go to 16 and 32, right? So while b less than n, this is to find the left j 2 to the right. So all of this L2p equal b, right? So while b is equal n, b, okay, so basically once we found that, right, 23, we're gonna go from 8 16 and we go to 32, right? We keep shifting left, go to 32, right? So 23 is between these, right? So we want to say if they shift, so let's just do this, right? We go out here, that means we found right power 2, r2p equal b, right? So like if shift 1 is equal to n, right, then this is the L2p, right? Like that. Okay, so now we want to do is we want to find the, what is it, ops, find ops of, right, this is um, R2P minus L2P. Okay, so it's gonna be the minimum of return, minimum of whatever this is plus 1, right? Because once we go to any power of 2, we should just subtract, and we got to 0 instantly, right? So that was that. So this is gonna be fine. If we go to the left, that's mean gonna be n minus L2P, and this is gonna be R2P minus n, right? So now we just need to do run operation, find ops on x, right? So basically we need to know for so start up so here we got a 2 to 0, right? 1, right? Y for I, okay, 2 to the 2, 2 to the 4, 2 to the 3, right? While b is less than x, right? Less than or equal to x. Right, we need to call find ops again on b, right? B shift left, right? So now we need to somehow cache them, right? But the base case here is if x, right, return the base case is, so we're gonna do is so we had 1, that's just gonna be gonna take gonna be 0, then op, right, operation op, right, put this 0, right? Okay, so that, right? So instead of that, we got 0, then we end plus 1, right? Off plus 1, right? Run this. Oh, we have to return. Yeah, I got infinite loop. Knew it. Okay, so be at 1, return 0. Let's say we at 10, right? We going to, let's see, hold on. The option for 10 is 9, right? 8 and 2 to the 1 0, 2 to the no, 0 is 1, 2 to the 1, 2 to 2, that's 6, 2 to the 3, that's 8 again, that's 2, right? Then 2 to the 4 is 16, and that's scratch, and so on, right? 8, 7, 6, 5, 4, 3, 1, 0, right? So basically we need to add a cache here, right? If not X, then cache of X. So if X is not in, if X is in the cache, then we just return cache of X, right? Otherwise, not in cache, so it's gonna be cache of X, gonna be equal to OP, right? Then return cache of X. Right? Right, so that's the cache. For example, if we land in 1, it's gonna return it's gonna return 1. Right? If it's landing on 3, 2, right? Then it's gonna be, we go to 0, go here, that means 1 plus 1 is 2, so 2 have some option, so we go on this, then it's gonna be 2 because 1 plus that, right? Otherwise we can go directly to 0, so that's gonna be 1, right? Because 2 minus 2 give us that, right? So basically we add 2 here, 2 to 0, okay. If B, right, so 2 can go to 1 or 2 can go to directly to 0, right? So basically we have to find the minimum here too, right? So basically minimum of go -1 of go minimum of equal requisite 1 or minimum of greater than of, right? Then minimum of equal to of. Okay, so then basically if go out here, cast of x gonna be minimum of, right? So that is that. So we have 2, we're gonna loop, go in here, 2 gonna found 1, right? 2 found 1, right? So the minimum of the 2 keep it 0, right? So now 3 go to 2 or 3 minus 1, right? Equal to 2. 3 minus 2 equal to 1. So if we go to 2, we have the value already that give us 0, right? Okay, hold on. So we add 1, that is 0, right? Right. So we asking for 3, right? Start at 3 is 0. We're gonna spawn to 1, 2. That's it. If we go to 1, 1 goes straight to 0, right? So that is 1, 2, right? And if we go to 2, we can go to 1. Wait, so this is 1, this is 2. 1 operation go to 1, 1 operation 0. So 2 can also go to 0 directly, right? Okay, so do we go on the top down or do we go bottom up? Like, so we have an array of 2 0 2 1 2 2 2 3, right? 2 4, right? So 3 gonna have started if we had 1, right? If we had 1, right? So 1 2 4 8 and 16, right? So we have that many. So we know that if we had 1, the max population is 0, not 1, right? Okay, so we somehow landed on 2, right? If we landed on 2, and okay, so if basically our cache can just store the power of 2, right? Right? So 2 to 0. So if we had 1, the maximum operation is 1. If we had 2, the maximum operation is 2 can go directly to just also 1. Right? Right, so actually our cache here can store our 1 is, so 0 is 0, right? 2 to the 1 to the 0 is 1, so that is 1, but it also landed on 2, and that's that, right? Right, so we have 3. We can have 2 options go to 1, right? So if this acts in cache already, right, then it's gonna be, so imagine we start at 3 here, 0, whatever, then we're gonna go right, our cache is will give us up to 2 already. So if 3 started at that, then wait, oh, this is x x minus b, right? Right, and basically we have 1 shift 1 is 2, right? Right, so it gives us 1. So basically if x in cache, then op okay, so just return cache, yes, right? So we are 3, we're gonna call on 3 minus 1, yeah, and then b ship another 1 is 2, right? We're gonna call on 1 and 2. It seems we call 1 and 2. It's gonna be plus 1, right? Right, so that's give us 3 gonna give us go 1 1, take 1 person to go to this guy, so 1 1, right? So the same. So at 3 it's gonna take 2, right? 4 can go 3 0, right? Yeah, right, so 5 can go 2 to 0 is go to 4, 2 to the 1, 2 to the 2 is 1, right? 2 to the 3 and so on, right? And so on. So because we go to 4, it's gonna take 1, right? So this is 2, go to 1, take 1, so 5, go to 4, and because we cast the 4 already, right, then yeah, this should be it. Return assets. Hope so. Oh, 2 65 got 3. So something that we did wrong. Okay, 39. Okay, let's go over them. 39. Let's print them out. Should be print. Let's just call this do print x. Oh, right. Return. Operation is cache x. This is in cache. This is 0. What? Then we go in here. We got right. Wait, did we do 39? So 2, 37. Oh my god. Somehow we off by 1, right? Somehow. All of these we off by 1. Right, so somehow we off by 1. So was that because of this? No. This is correct. Right, so let's first print out LP and RLP, right? Zero. What? Guess that's the issue maybe. So we want 39. Where's 39? 39, 132, and 64, right? Okay. 39, 164, and 32. Okay. Okay. So we want the moment it is greater than the moment, this is n. We want the number before it is greater than or equal, right? So this is wrong. But I'm also tired. Okay. So we start with a number. And you want the last number where, so the left one is the last number, last 2 to the power, that is less than or equal to equals sign to n, right? So the moment it become greater than or equal to n, the moment it become greater than is when we get the value right. So this is the moment before it become n or greater than n, right? So that should be this way, right? Yeah. So we got 32 and 64. Good. Okay, so that means 39 minus, that's 7, and the other one is the other one is 64 minus 39 is 25, right? So out of these, whichever one give you the minimum, that should be it. So you got 7 gonna have, so this is the one, right? 65432, right? It's in cash. So this week, let's just put our loop. Right. So 3 is 2. Is that correct? 3 go to 1, 1 go to 0, 3 go to 2, 2. Yeah. 4 is 1. That's true. 4 is 0, right? Oh, 4 is 1 is correct. So 22, 3. Alright, so let's do, maybe it's not too bad. So 7 here. So 5. If we land on 4, right? Operation gonna take 4 can go to 3. 4 can go to 2. And 2 to 0 is 1. This is 2. 2 to 0. 2 to 2. 2 to the 2. Wait. 4 can go minus 1, which is 2 to 0. 4 can also 2 to the 1. And then 4 can minus 4, right? So 4 gonna have 3, 2, 0, right? So 3 gonna do 1, 3, 2, 1. Okay, so like 2 here, 2 to 0, 2 to 1 here, 3 minus 2 is 1. Right? So in 2 here, the max is actually 1, right? Both of these, right? So now if you see 2, so 4 gonna be 2, right? So if I'm at 4 and I go to 3, okay, so let me print the cache and see. Right. But also we might have to start probably soon because it's lunchtime maybe. 2 is 1, right? Yeah. Let's see. Is 3 is 2? 3 is 1 to 1. You can go 1 or 1 to 2. Yeah. 4 is 1, good. Right. So we want to know 7. Where's our 7? 7 is 3. And they want 3. Right? 25. What the hell is 25? Or is it just this is wrong? No, right? It's off by 1k. So I think I'm gonna stop here, I guess. I'll be back after lunch. After lunch, we gotta play some games. After we play some game, then we'll be back then, I guess. So let me see. So we have lunch for 30 minutes. So play game at 1 to 3. Then 3 to 5, we can do that. Right?